Welcome back, everybody. This is our first class in NEET previous year questions for chapter Electrostatic Potential and Capacitance. This chapter is a subtopic related to chapter Electrostatics of your class 11 or 12th, sorry. And this is our first video in this chapter series. And before this, for previous videos, you can check out our channel's playlist section where we have made various videos related to NEET previous year. We have completely covered first chapter of class 12th and also class 11th up to 2024. So you can watch those videos, and if you found them useful, then you can like them, share them, and subscribe to our channel. Also, if you want to support us financially, then you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. So with this, let's start with today's video with question number 1. Let me adjust the thickness slightly. So in a certain region of space with volume 0.2 meter cube, so volume is mentioned to be 0.2 meter cube, the electric potential, so potential is 5 volt throughout. So we have to find the magnitude of electric field in this region. So we have to find electric field. Now let me choose different color. So as per mention that we have to find electric field, we have given some potential and some volume. So first idea can be that what we can do, we can consider that whole space as a cube. What we consider that we have a cube, and volume of that cube is equal to 0.2 meter cube. From that we can find the side of cube, that is given to be cube root of 0.2, or we can say 2 by 10 power 1 by 3. Now we know that electric field and potential are related with this formula, that dV by dr, where dV is change in potential and dr is change in distance. So as per mention that it is 5 volt throughout, means it is value of potential is constant through whole this cube or whatever, if you consider a sphere or throughout the region, the value of volt potential is constant, so this dV is 0. So if this dV is 0, then electric field will be 0, and option D will be the right answer. Moving to next question. Bullet of mass 2 gram having charge 2 microcoulomb through a potential difference must be accelerated starting from rest so that it requires speed of 10 meter per second. Now here we can apply energy conservation, that whatever the energy acquired by the bullet, that is kinetic energy, so half mv square should be provided by the electric potential, and the work done by an electric charge in electric field, in electric potential is given by q times the change in potential. So here we half mv square, or value of v is given, value of mass is given, so putting those values, 10 into 10 is equal to microcoulomb, so 2 into minus 1 minus 6 into potential, so 2 get cancelled, and this 10 raised to power 6 will come here in the divide. So this is 10 raised to power minus 1 by 2 into 10 raised to power 6 is equal to V. So this will be 10 raised to power 5 by 2, or 10 into 10 raised to power 4 by 2. So this is 5. So 50 into 10 raised to power 3, that will be 50 kilovolt. So right answer will be option B. Moving to next question. Value of electric potential at a distance 9 centimeter from the charge. So value of charge is given, and we know that formula for electric potential is given by K Q by R, where R is the distance from the charge or center to center distance. Now value of k is 9 into 10 raised to power 9. Value of q is 4 into 10 raised to power minus 7. And distance is 9 centimeters, so 9 into 10 raised to power minus 2. This get cancelled. This will go top, and 9 plus 2 11 minus 7, and that is 4. So 4 into 10 raised to power 4 volt will be the final answer. Option D is the right answer. Moving to next question. Variation of electrostatic potential with radial distance from the center of a positively charged metallic thin shell. So here it is mentioned that is a thin shell. Now we know that in case of a thin shell, inside it electric field is zero and potential is constant, and it is equal to value of potential at the surface. So for inside, for R less than R, value of potential will be equal to value of potential which is at the surface, and outside it will be proportional to 1 by R as normal potential formula, and that is the graph B, which satisfies both of these conditions. Moving to next question. Electric potential at a point in free space due to charge q coulomb is q into 10 raised to power 11. Electric field at this point is, so we have to find out value of electric field. Now for that, what we can do, considering we have a distance r, the value in free space we consider some point which is at distance r, and at this distance r value of potential is this. So we can say V is equal to 1 by 4 pi epsilon node into charge by r, and this value is given to be q into 10 raised to power 11. So this we know. Now we have to find the electric field. Now formula of electric field it is 1 by 4 pi epsilon naught q by r square is equal to electric field. Now we can simply divide them, but if we divide them, then we will be left with 1 r in the denominator. And here in the options we don't have any value of r. So what we do here, from this equation we will find the value of r. So q get cancelled, and r is equal to 1 by 4 pi epsilon naught into 10 raised to power 11 plus 11. This will go in the denominator. Now we will use this value here. So 1 by 4 pi epsilon naught as it is, q as it is, divided by r square. So r square will be, this is r, so r square will be 1 by 6, or we can say 4 pi epsilon naught whole square into 10 raised to power 22. This whole term will go up. So 4 pi epsilon naught square 10 raised to power 22 with q and divided by 4 pi epsilon naught. This square get cancelled, and we will be left with 4 pi epsilon naught q into 10 raised to power 22. So option A will be the right answer. Moving ahead, as per diagram, a point charge plus q is placed at the origin O. Work done in taking another charge minus q from point A to another point B along the straight path AB is. So as we know that work done only depends upon, in case of electric potential, work done only depends upon initial and final position. So it is like a state function. So we can find out, to find out the work done, we can find out energy of particle at point A. So EA, and energy of particle at point B and EB. After calculating both of these, work done will be difference of both of these, so EB minus EA. Now we know formula for EA is equal to 1 by 4 pi epsilon node, at center it is plus Q, and distance between O and A, because the coordinates of O and A is 0 comma A, and for coordinates of B are A comma 0. Now distance between OA will be A, and value of charge at A, that is suppose Q. We are considering the value of charge at A is Q, and at B is also Q, because we are moving charge from A to B, so same charge will be there. Now EB, if we find out, again 1 by 4 pi epsilon node, charge at center is small q, distance from O to B is again A, and this is the energy. Now both of these are same, so their difference will be 0, so option A will be the right answer. Moving to next question. Given below two statements, one is labeled as assertion and other is labeled as reason. Potential V at any axial point at 2 meter distance from center of a dipole P of magnitude this is given by plus minus 9 into 10 raised to power 3 volt. So for a dipole, potential is given by this formula. V is equal to 1 by 4 pi epsilon naught P cos theta by distance square. Now, as mentioned, that point is axial point. So suppose this is our dipole and this is the direction of dipole. Now this point can be on right side and can also be on the left side. So cos theta can be either 0 or 180. So we will take it as like positive negative 1 by 4 pi epsilon naught, because cos 0 is 1, cos 80 is minus 1. So that's why positive negative sign P by R square. So 1 by 4 pi epsilon naught is 9 into 10 raised to power 9. Value of P is mentioned 4 into 10 raised to power 6. And distance R square will be 4. So this will be with plus minus sign. This will be 9 into 10 raised to power 3. And this is the mentioned answer. So option A is right. Now going to B, reason, where R is the distance at the axial point situated 2 meter from the axial. Potential value is given as 2p by 4 pi epsilon naught r square, which is wrong. Actually, we have find out the value of potential is will be 1 by 4 pi epsilon p by r square. So here we have extra 2 which should not be included in the formula. So assertion is right and this is wrong. So A is right, B is wrong. Option B is right, R is false. Moving to next question. Let me make it slightly thicker. A short electric dipole has a dipole moment is mentioned. Electric potential due to dipole moment at a point at a distance 0.6 meter from the center of a dipole situated at a line making angle 60 degree with the dipole axis. So here we have angle as 60 degree and formula will be the same which we used in the previous question, that V is equal to 1 by 4 pi epsilon naught P cos theta by R square. So this value is 9 into 10 raised to power 9. Dipole moment is 16 into 10 raised to power minus 9. Cos of 60 is half and 1 by R square. So distance is 0.6. So 6 by 10 or 6 into 6, 10 into 10. So this will cut at 8. Now 4, 3, 3, 2, and 2. So we will be left with 2 into, this is positive 9, this is negative 9 into 100. So 200 volts. Option A will be the right answer. Moving to next question. Thin spherical shell is charged by some source. So it is a thin spherical shell. So it is empty from the inside. The potential difference between the 2 points C and P as shown in the figure. So we have to find the potential difference, and actually we don't know exactly that where point P is. So suppose this point is at surface. We are assuming that this point is at surface. So if this point is at surface, and we know from the definition from a spherical shell that its potential at surface will be given by charge by 4 pi epsilon naught into its radius, and inside a spherical shell at any point, um, suppose point C, and it can be anywhere inside this empty shell or hollow shell, is again equal to q by 4 pi, where r is the radius. So potential at these 2 points will be equal, and if you find the potential difference, it will become 0. So option C will be the right answer. Moving to next question. Two hollow conducting spheres of radius r1 r2, where r1 is greater than r2, have equal charges. Potential will be, so we have to find that potential will be higher on which of one of them. So suppose this is our first sphere and this is our second sphere. Now as per mention that suppose this is radius r1 and this is r2, and as per mention r1 is greater than r2, but their equal charges, so their charges are equal. So this also has q charge and this also has q charge. Now to find the potential difference, we have to use the concept of capacitance, and we know that q is given by, for a capacitor, q is equal to c into v, where c is capacitance and v is radius. So from this, potential on a capacitor will be q by c, and these are spherical in shape. So for spherical shape, capacitance is given by 4 pi epsilon naught r. So v1 will be proportional to 1 by r1, because charge on both of them are same and 4 pi epsilon naught is already constant, and v2 will again be proportional to 1 by r2. So v1 by v2, this ratio is equal to 1 by r1 divided by 1 by r2, so that will be r2 by r1, and we know that r2 or r1 is greater than r2. Oh, sorry, not y diagram, this should be r1 and this should be r2, because r1 is greater than r2. So r1 is greater than r2, it means r1 by r2 is greater than 1. What does it means? And let me correct it here. This is our first sphere and this is our second sphere, so we don't have any problems. So from this, v2 by v1 is equal to r1 by r2 is greater than 1, or in short v2 is greater than 1, and v2 is our smaller sphere. So smaller sphere's potential is more, so potential would be more on smaller sphere. Option B will be the right answer. Moving to next question. Two charged spherical conductors of radius r1 and r2 are connected by a wire. If the ratio of their surface charge density of the spheres, sigma 1 by sigma 2, two charge. Okay, so again we have two charge conductors, one, two. Now this time we will mention with proper names. So this is A, this is B, R1 and R2. We have to find their we can say ratio of their densities, and we are given nothing except. Then so suppose, let's start. As per question, we have connected both of these by a wire. Now, when they are connected by some wire, then what happens? Their potential becomes equal. So V of A is equal to V of B because they are connected by a single wire, and after some time their potentials will become equal as their charges will interchange somehow due to wire connection. So suppose its charge is QA, final charge we are talking about after interchange, and its final charge is QB. So their potentials will be QA by 4 pi epsilon node radius R1 is equal to QB 4 pi epsilon node radius R2. 4 pi epsilon node get cancelled. So QA by R1 is equal to QB by R2. Now we have to find the ratio of densities. Now sigma 1 by sigma 2 that we have to find out, and sigma 1 will be QA by 4 pi R1 square, and similarly sigma 2 will be QB by 4 pi R2 square. So 4 pi get cancelled, and we will be left with QA by QB into R1 square by R2 square. Now from this, QA by QB is given by R1 into R2. Putting this value here, R1 by R2 into R2 square R1 square. So this square terms get cancelled, and we will be left with R2 by R1, and option B will be the right answer. Moving to next question. 27 drops of same size are charged at 220 volts each. Then they form a bigger drop. The potential of bigger drop will be. So we have 27 drops. Suppose each drop has a radius of r, and if its radius is r and it is charged to 220 volts, so its potential is 220 volt. Now, when we combine 27 of these kind of drops, then what things will be remain constant or conserved? The first will be charge. Charge will remain conserved. That charge of bigger drop will be 27 times of charge of smaller drops, and also volume will stay constant because these are liquid drops. So volume of bigger drop will also equal to 27 times of volume of smaller drops. So suppose first we will solve for volume. Suppose this is our bigger drop and its radius is capital R. So 27 times volume of small drop 4 by 3 pi r small r cube is equal to 4 by 3 pi capital R cube. So 4 by 3 get cancelled, and from this r comes out to be 3r. This is the radius relation between radius of bigger drop and small drop. And now coming to charge. Now charge is given by C times V, where C is the capacitance, and capacitance for this small drop will be, as this is a spherical drop, so it will be 4 pi epsilon nodes, its radius small r, into its potential, that is 220. So effectively it will be 880 into pi epsilon node r. So this is the charge of one single drop. So now charge of bigger drop will be 27 times of this value, 880 pi epsilon node into small r. Now we have to find the potential of bigger drop. Now potential of bigger drop VBD, potential big drop should be equal to charge of big drop by capacitance of big drop. Now charge of big drop is given by this 27 time 880 pi epsilon naught small r, and capacitance of bigger drop will be again 4 pi epsilon naught capital R, and capital R is equal to 3 times of small r, so 4 pi epsilon naught into 3r. So this will be 4 into 3 into pi epsilon naught r. So pi epsilon or r get cancelled. This is 9 and this will be 220. So 0, 8, 18 into 1, 19. Option D will be the right answer. Now moving to next question. Two metal spheres, one of radius r and another of radius 2r respectively, have the same surface charge density sigma. They are brought in contact and then separated. The new charge densities of them. So let's solve this. Suppose this is first charge sphere of radius r and this is second of radius 2r. Initially they have same surface densities, so sigma is sigma. Now they are in brought in contact. So when they are brought in contact, what will happen? Their potential will become equal. When they are brought in contact with some wire or they are touch with each other, their potential will become equal and their charges will redistribute. And there will be also condition, one more condition on the charge, that total charge will remain conserved. So suppose their initial charges will be, as we know that charge density is sigma and sigma is equal to charge by area, surface area 4 pi r square. So their initial charges will be sigma times 4 pi r square and sigma times 4 pi into 2r square, that is 4r square again. So 16r square, sigma times 16 pi r square. These are their initial charges. Now suppose final charges are QA and QP. So from our statement that charge total charge remains conserved, QA plus QB should be equal to sigma 4 pi r square plus sigma 16 pi r square. So it equal to sigma 20 pi r square. So QA plus QB is equal to these values. And QA and QB are the final charges of both of these spheres. Now, second condition which we will use, as I already discussed, that when we connect both of these, their potentials become equal, and potentials are given by charge by capacitance. So capacitance of first sphere will be 4 pi epsilon naught r, and potential for second sphere will be charged by capacitance of second sphere, so 4 pi epsilon naught 2r. So 4 pi epsilon naught 4 pi epsilon naught get cancelled and r get cancelled. From this, QB comes out to be twice of QA. Putting value of QB here, so QA plus 2QA 3QA is equal to sigma 20 pi r square, and value of QA comes out to be 20 by 3 sigma pi r square, and value of QB then comes out to be 40 by 3 because it is double of QA, sigma pi r square. Now calculating the densities. So density of first sphere will be charge by area 20 by 3 sigma pi r square, and its area will be 4 pi r square. So pi r gets square get cancelled and this is 5, we will be left with 5 by 3 sigma. So here it is, only this option which have 5 by 3 sigma. Now calculating similarly for sigma b, it will be charge of second square 40 by 3 sigma pi r square by its area, that is 4 into pi into 2r square, so 16 pi r square, 16 pi r square. So pi r square get cancelled and this get cancelled at 10, at 4, 2, 5. So 3 will go to denominator, 5 by 6 into sigma. So second option also satisfies. So option D is the right answer here. Moving to next question. 4-point charges minus q, minus small q, 2q and capital 2q are placed one on the each corner of a square. Relationship between q and small q at which the potential at the center of the square is 0. So suppose this is our square, and as potential is a scalar quantity, so we can randomly put charges anywhere on any of the corners. So here 2q and here capital 2q. Now as we are calculating potential at the center, so distance from the center to every corner is same, and suppose that is given by small r. So and center point is O. So potential at center will be 1 by 4 pi epsilon naught into minus q by r minus q by r plus 2q by r plus capital 2q by r. This is the combined potential at the center, and if this has to be 0, then we can also take 1 by r common. So 1 by 4 pi epsilon naught r minus q plus 2q plus 2q. So if this potential has to be 0, this whole value, whole term should be equal to 0. And for that, this term should be equal to 0, and this will give us plus q. This will also give us plus small q is equal to 0, and q is equal to negative small q. So option A will be the right answer. Moving to next question. Three charges, each of plus q, are placed at the corner of a isosceles triangle ABC, sides BC and AC 2A. So value of each side or length of each side is 2A. D and E are the midpoints. D and E are the midpoints of BC and CA. Work done in taking charge Q. There is a charge Q from D to E. We have to find its value. Now we have positive charges here. Again here positive charge. So to find out the work done, what we have to do? We have to just calculate total energy of charge at E point. So we can say energy at E point, and we also have to find out energy at D point. And then what we can do, then we can easily subtract them and find the work done. Now let's start with E point. We are doing here calculation for the point E. Now if charge capital Q suppose is here, then its energy, there will be energy due to charge at A and charge at C. Because this total length is 2A, so this distance will be A, and again this distance will also be A. So here energy EE will have two terms, first from charge A, second from charge C, and third from charge P. So from charge A it will be K Q by distance A. From charge C it will be again K Q distance A, plus from charge B it will be the distance BE. So K by BE. Now for D point. Suppose now charge is at point D. So now charge is here. So energy at D point, this charge will have energy due to charge at C and due to a charge at B, and again these distances are equals to A. So same terms will be there, plus due to both of these charges. Now due to charge A, this there will be distance AD. So K AD. And we know that this is an isosceles triangle. So length of BE is equal to length of AD. So BE and AD are equal. All other remaining terms are equal, means EE is equal to ED. So at both of these points, energy of a charge is equal. So if we have to find the work done, then we have to subtract them. And when we will subtract them, we will get zero as they are equal. So moving a charge from point E to point D or vice versa will not require any work done in this case. So option C, 0 is the right answer. And with this, we finish this video here. Hopefully whatever we have covered will be helpful and useful to you. Again, if you find this video useful, then do like this video, share this video as much as possible, and subscribe to our channel. Also, we have started similar series for JE also, and if you are preparing for JE, or some of your friend are preparing for JE, or if you want some advanced question preparation for your NEET exam, then you can look into those videos. They are available in our playlist section. And if you have again coming any comments, doubts, or suggestion, then you can put them in the comment section. And also, if you want to support us financially, you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. Now, with this, again, thanks for watching, and we will meet in next video.